Hello, so you can hear me, right? So this is gonna be another topic, method 24. It's calc 1, and we're going to talk about like the tangent line and or like velocity problem. And this is like last topic before we into like the real calculus topics. So it could be section 2.1. I would just call like this secant line and velocity problem. Page 4, I think. So in method 24, it is differential calculus. And we mainly learn like the limit and the rate of change. It's like a limit, differentiations, and like rate of change and the application of the differentiations. Like make limit and the rate of change. Derivative and applications. Okay, here's like an example here for 2.1. So perhaps you have 45 ounces of water at 1:40 p.m. while it's a leaky bucket. By 2 o'clock p.m. sharp, you have 10 ounces of water left. And then what's the rate of change? And how we define the rate of change is we have a total amount of change over total time elapsed. Over total time elapsed. So here, the first example here, we have 45 ounces initially, but we have 10 ounces of water finally, and initially it's 1:40, and it's 2 o'clock, so the time elapsed is 20 minutes. If you want to calculate that per hours, then 20 minutes is just 1/3 hours. So it's 1/3 of hours. So in this case, the rate of change, it is total amount of change is equal to 45 minus 10 and over by 20 minutes. And we have this 1.75 ounces per minute. And this is a rate of change. Here you just have like numeric values. That's why we use this function, use this equation. While if you have a function well defined, then the rate of change could be if you have an interval A and B, on a function called f of x, then the rate of change is it is equal to fb minus fa over b minus a. It is the rate of change in the time in the interval, while b minus a it is the time elapsed. fv minus fa is the total amount changed. Let's do an example here. So it's like, so we define like a rate of change. For example, if we have f of x, it is 2x squared minus 1 from x equal to a 0 to x equal to 9. Find the rate of change. So we have this well-defined function, time interval a is 0, b is 9. So the rate of change is equal to f9 minus f0 over 9 minus 0. And what we have is 161 minus 1 over 9. You've got 162 over 9 is going to be 18. And this is like, and then we can introduce average rate of change. It's the same as average velocity. I always refer to the average velocity. So do an example here. So actually there's like a butterfly. is moving along, is flying along a straight line. Then its position function is defined as v t over t to the fourth minus 4t to the squared and plus 24. Compute the average velocity of the butterfly from t equals to 1 to t equals to 5. So maybe pause the video, maybe try done wrong. See if we can do the same problem on the actual exam or the final, because I can't do any exam for you. You have to take your exam on your own. Because you're a college student, you have to take the responsibility that I'm only a helper, but I can't take the test or do the homework for you. You are the learner. I'm the helper. We work hard and we make the thing happen. So let's find the total time changed, total time elapsed. This would be 9. We'll try 9 again. 9 minus 20 equals 8 is total change equals to V9 minus V1. And then we have total rate of change, or it's like average velocity. It's V9 minus V1. Let's compute what is V9 minus V1 over 9 minus 1. What you have, it is, grab a calculator here. So what I need to do, it is 9 times 81 is 81 squared. Minus 4 times 81 is 324 plus 24. 6,261 minus 3, 1 over 8. It is 6,240 over 8. And what we have, 780 is average velocity in this time interval. Let's do another example here. Example 3. There's a toy car. It's moving in your living room or on the floor. And with a position function, what you have it is another VT is t squared minus 2t and a plus 8 over t plus 3. Perhaps it's the function. Compute the average velocity from t equals to 0 to t equals to 5. Maybe pause the video, try it out wrong. Perhaps it's on the actual midterm. Forgot it's page 5. And let's roll. Average rate of change. Or V average velocity. It is V5 minus V0 over 5 minus 0. And we have it is V5, 25 minus 10, 15, 23, 23 over 8. Minus 0, it is 2 minus, it is 8 over 3. It's 5. Then what you have it is 2469 minus 64, so it's 24 over 5. So we're going to do 1 over 24 is our average velocity. And we talk enough about the velocity and average velocity rate of change problem. And now we jump to what is a secant line. It's a new concept. And so what is a secant line? Perhaps we have two xy coordinates. Two function. One is called f of x. Another one it is g of x. It is not a function. G of x, f of x. Point A, point B, point C, point D. The first one, top one, we call the purple line. First one is the purple line. The second one is blue line. Second one is like second one is like sky blue line. Then take a guess. Fx is tangent line, or gx is tangent line, or which one is secant line, and which one is the tangent line. Well, you take a guess. Okay, let's just show what the answer is. Secant line is a line that connect two given coordinate, or it's like the slope, the average rate of change between point A and point B is the rate of change. While this next one in the GX, it's a tangent line. Tangent line is the line that only touches one point. But does not connect to another point. It can pass any point of the function, or intersect. Already many points. So we can also call that the slope of a secant line, it is y2 minus y1 over x2 minus an x1. So perhaps A is x1 and the y1. For B, it is x2 and the y2. And the slope we call the M. Slope of secant line. And what we have, it is, and we call them M. M, it is y2 minus y1 over x2 minus x1. Well, how to another challenge is how to approximate the slope of the secant line. Slope of the secant line. Again, we do not have any technique to find like whatever slope beside the equation of rate of change. Any differentiating technique learned yet? Or limit learned yet? Why? Because method 24 at UW just assume you do not have any AP calculus background. You just have just done a pre-calc and then you head college. You may not have any mathematical background. After pre-calculus. So we just use the table approximating. We call it table approximating technique. Table approximating method because the TM or TAM. For example, here we have a function for x squared f of x, it is 4x squared. We then compute the slope of the secant line or the slope of the tangent line. At x equals to number 2, x equals to 2, then approximate the slope of the tangent line at x equals to 2. So obviously, we can't use derivative. Actually, the slope of a tangent line, it is the derivative, but we can't do it right here. So what we do is we list like a table. So we take the nearest point. So we can take a point on the curve f of x. For example, x equal to 1.95. A is the output of y value here. This point we have is a 1.95, and we have is 15.21. And the original point is f2. It is 16. And we can do like the rate of change. Or the slope of secant line. It is f2 minus f1.95 over 2 minus 1.95. And what we have is 16 minus 15.21 over 0.05. And what we have is 15.8. If we take another point, another point on f of x for another example here. (2.02). B is the output for y. (16.322). And the rate of change is the slope of a secant line. And we have f 2.02 minus f 2.02 minus 2. What we have it is 0.322 over 0.02. And what we have it is 16.1. And then how we do this 1 point, it is actually is smaller than 2. And at 1 point with x larger than 2. So the slope of a tangent line at x equal to 2, it's just between those two values. between the two output. Now you can see it's 115.1, 116.1. Then the slope of the tangent line at x equals to 2, it is 16. This is correct. There are two ways we can get how y it is 16. If you take a limit, x equal to 2, 4x squared, it is 16. It's like the limit. Well, we can take the derivative. Here's a concept that I introduced early, but not used in chapter 2. Now used until like chapter 3. That's all for 2.1, the tangent line, the secant line, and the velocity problem. And next video going to be at 2.2 and 2.3, which is like the limit and limit mechanics. Thank you guys for watching. Have a great day.